Alright, sir. So we work with what we have here. We just work with one of it so that you can understand the way it works. So I'll work with this our own DNA sequence that we got, and we'll conduct blasting on it. So I'll work with AU2 because I want to show you something specifically. Yeah, so if you come to this place, your Chrome browser, just type blast NCBI. Those are the major keywords you need to get to the website. So usually it's the first one here. So because we want to conduct nucleotide blast, this is for protein blast. So click on this, and we already copied the nucleotide, the DNA sequence for this particular organism. So in case you want to use a specific range of, from this sequence to search for other organisms, let's assume you just want to search from, you want to use this particular section to search for other organisms, you can put in that, okay, from range 1 to range 200. That's what that particular place is for. Then these are databases, the database you want to search from, but you really do not need to tamper with it except you have something specific you want to work on. So usually I use the standard database. I just click on that and I similar sequences. Then you click blast. Then if you want it to show in another tab so that you can come back to edit what is there, you would enable this option. So I'll just do that so that we can see what it looks like. So I'll click on blast, so you can see, so that we can still come back to this place. That's because I enabled this. However, if I do not do that, it will just load over this page and we might not have access to our settings here anymore. So this usually doesn't take time. Yeah, exactly. Now we have the outputs. These are the results of microorganisms that have similar DNA sequence with our query. That's what we searched for. So, and the accession number of what we searched for AEO2 is CP019986, CP019986, CP019986. So we have it on the second row here. So you can use this to select all and select all at the same time. So this is the maximum score, this is the total score. There's a whole lot to it, but the basic thing you need is what I've just tried to show you. So you can select the microorganisms you want to use. So usually we select those with higher percentage of identification. This percentage identification, this e value is like error value, like expected value, that's tendency for error. So since the smaller the tendency of error, the more accurate the result is, or the more better it is. Although that's not the exact meaning, but that's just like a lay way I can break it down. That tendency of error in this result. So tendency of error in this result is 0. And query covered. This query covered means it used 100%. It used all the DNA sequence, the nucleotide in that DNA sequence. That was what it used to search for this result. That's why we have this result. And we can see what we have here on the second row is 99.40% close or closely related to what we searched for. So just going to pick another one because I want to show you what complete sequence and aligned sequence looks like. Yeah, so that we know. I'll just call this complete, and I will download the aligned too, so that we'll see. So I'll explain the differences between both of them so that you know the one you want to use. Let me just download this again, I think. Okay, so I have that I have that downloaded already. So for the complete, so the complete will give you all the DNA sequence for that particular organism without segmenting it, without breaking it down for one particular trait or or gene like that. Unlike this aligned one, let me show you what the aligned DNA sequence look like. The same organism, but if you look at this aligned, you see that it's broken down into like segments. It still contains almost all the DNA sequence, almost all, not exactly all, but it has segments. So, and these segments are responsible for particular traits or gene. So that's this is the difference between the aligned and the complete. This is the complete. The complete will give you everything without breaking it down. Now, why do we use aligned? Aligned is only used if you know the particular segment of the gene you want to search for. If you know the particular part of it that you want to search for, that's when you can use aligned. But if you don't know, it is best to use the complete so that the mega software will do the alignment itself, because this particular part might not really be the part that is closely related to what you're looking for. There's a way to check for it. Let me use the alignment to explain to you. So if you check the alignment here, you see that from this part query 4 to query 63, we have some parts that do not match, right? We have some parts that do not match. For this whole part, everything matched there, everything matched there, everything matched. But we have other parts that will not match, that like this part now did not match. So if you cut out, if you use like an aligned file like we downloaded earlier, if you use the part, you don't know the exact part, so there's tendency you might delete it in the process of you saying, okay, I want to reduce it. Now, but for the complete sequence, it has everything. So once you bring that into mega will do the alignments itself. So mega will do the alignments itself. That's why I prefer using the complete sequence. So let's take an example using this, because the sequence is actually smaller, so that the tutorial will not take too long. Okay, so we want to blast now. We'll come to this place like we came earlier. We can now you click place the DNA sequence. This is selected by default, it should be selected. So we will blast and I'll close this so that it doesn't get confusing. I'll delete all of these. Okay, now that we have our results, if you check, you will see our, let's come to our file AE01. This is our session number OM179766. So if you come here, you see it too, but the percentage education is 94%, so it's not exactly 100. Sometimes you might get as high as 99. It depends on how closely related they are. Now I'll pick just two so that I can, or let me pick about five of these. So I'll download their complete sequence. I prefer working with complete sequence. So I'll download their complete sequence and name it complete sequence. So it doesn't take much to download actually. Now when we open that, we have different, so we can decide to work with it like this. But something I used to do is I'll come to the last nucleotide and press enter so that the work can be neat for me to see. The work can be neat for me to see and read easily, because I'll still have to edit it. So the edit you have to make to this for it to be easier for you. You can because this first line is the name that will appear on the phylogenetic tree. There are other ways to do it, but this is like the most simplest way. So anything you don't want on the name line, you remove it. How do you identify the name line? The line has an arrow first here. If you check this too, it has an arrow. That's how we identify. So whatever I don't want to appear on the phylogenetic tree as the name, I'll just remove it. I'll just remove it. And because I did not download the the organism that had similar the organism that has similar DNA sequence with the same accession number, I did not download this. I only ticked this. So I will come here, copy this one and add. But so that it will be easy, I will copy the accession number here and add myself. Then I will copy the organism name too and add it here. So I'll just select all of this here to this place, copy and paste. So I can paste it at the end. The arrangement doesn't really matter as long as it's not changing anything like this or pasting in between something. There's no issue. So I'll just save this. So to save this, you can use Control X, but if you Control X, but if you want the file to be more organized, you can come to save as. So I can come here and say edited sequence. After choosing it as edited sequence, in case there's something you can do here directly, but so that you don't make mistake, right? You can, after saving it as edited sequence, you will not save it again as that same name. You cancel the tst at the back. There's no way to, okay, let me see, there's a way to enlarge this. Okay, so there was tst here like this. You cancel it and change it to FASTA, FASTA. So it's called FASTA format. So this FASTA format is the format that is readable by the mega software. The file format is just like we have document format, PDF format. So we'll come to mega. You come to mega here and you click align. You build alignments. There's no way to increase this, but you build alignments. So if you ask you, do you want to create a new alignment or retrieve sequence from a file? We want to create a new alignment. So are you building a DNA sequence to are you building a DNA sequence or protein sequence? We are building a DNA sequence. So we select DNA. So to bring this, you just right click and hold and drag this. Then you click on this box to maximize it. Now you come to data, open saved alignment session. Do you want to save it? Yes, we have to save it. If you save this alignment session, so what are we going to save that? I'll just save it as live example. So it, sorry. So okay, now open, then we'll come to retrieve sequence from file. Retrieve sequence from file. Now under retrieve sequence from file, if you not click retrieve sequence from file, you not see that FASTA format. So this is the edited sequence that we save as FASTA. So once you load it in, you have something like this. You have something like this. So we want to perform alignment now. For us to perform alignment, we click on the first one, press and hold shift, then click on the last one. Click on the first one, press and hold shift, click on the last one. Then come to alignment, click on align by module. There are different ways to align, but we use module primarily. Then you don't have to change anything, just click on OK. So depending on the size of your file, it will take time. Now this has been aligned, and whoever doesn't have equal nucleotide, you can see it there. So this minus means, or this dash means a missing nucleotide there. So after we have this and we have this saved, after we have, you can minimize here and come to this place, come to from, because we already have this place. Remember that if you click on this, we already did the alignment here. We already did the alignment, so we don't need to do much here again. You might only save this file, but we already saved this file, so we don't need to. This is as the live example. You can save it again, but since you are working on it, because once you have already saved this file, even if you close the app or something happens, because you saved the file, you can just come and continue from here. That's the reason for saving the file. So you can close the or minimize this. You come to phylogeny and neighbor joining trees. That's what we want to use. Then this place, make sure it's on all files so that you see this document that has let me see a way to increase it. This document that has MAS, not this FASTA, is all want to use. So click on that. We open it. Then it will ask you protein coding nucleotide sequence. No. So bootstrap, number of replications. This is what I was explaining that day. That can be 100. So if you want to change that, but 1000 is fine. And just click yes. Okay, now we can maximize this here. We have our phylogenetic tree. Now we have our phylogenetic tree here. To edit one or two things there, you can come to this part that looks like a spanner and want to add labels. So for this label, I want to add a shape. This is just similar to what I did, so I'm trying to show you. But this shape, I want to add this for this particular file. So I'll click OK. So that's how to add this. Then I can decide to adjust the length, the width. I can adjust the length too, but I don't want it to be too long. The height. So these are places where you can change one or two things. Then the tree style. So if you want to change it, so go. This is the traditional one that we use. Then this is the bootstrap sensors, but this one is better. This one you just need to use. It's pretty much the same thing, but this is all you need to use. Then click on. So there's nothing you really need to change here again, except you just want to change one or two things. Except you just want to change one or two things. Then you want to display caption. This one will just give like an idea of the relationship between the tasks, and but it's nothing much. So this is the process of creating phylogenetic tree. You just, the major part is this part where you have to like bring your files together. After constructing your phylogenetic tree, so after constructing your phylogenetic tree, to export it, you can come to image, save PNG. So we click on this and type the name of the document. Let's say life example PNG. Then we save this. Then click OK. So it will export. This is it. So we have the image here. Then if you want to turn it to PDF, you can import this to your Microsoft Word to give it a better look. And if you want to save it as a PDF directly, you can also use PDF tools online. Just search for convert image to PDF. Then you find the tools. That's the basic way, sir.